Alright, in this video what I'm going to do is introduce the concept of Anova to all of you. Again, we've already established how to do hypothesis tests for two populations. Anova is a generalization of this comparison among different populations where we're trying to figure out whether some variation we see in data can be explained by a categorization of this data. So the data set we're going to use for this example is a pseudo data set where we have how much people are willing to spend on leisure activities over the course of a year. And we have some basic information about them. One piece of data is their age, another is their gender, another is their favorite leisure activity, like what do they want to do? Do they want to spend it on, some of our examples here are cars, whether they go to clubs, whether they go spend a lot of time outdoors, or whether they spend a lot of time traveling. And so what I'm going to do is, to start off, we've got a lot of observations, and so we're going to take a look at the actual distribution of the data. So these are the number of individuals who spend a particular value, and what we're going to do is try and hypothesize some categorizations that might explain variation in this data. Now, if we look through this, it definitely does not look like a unimodal distribution, which tells us there may be multiple populations in this distribution. Okay, we see a spike here at $20,000, we see another spike at 22, and another spike at 23,400. So what I'm going to do is I'm going to create histograms here, where I'm just going to break this down by gender. And I've already done this for you, so you don't have to worry about it. But what we'll do is we'll break this down, and we'll look at whether or not particular characteristics explain the variation in the data we observe. So I'm going to look at the distribution of expenditures by gender here, with the potential hypothesis that men and women spend on average different amounts. But if we visually look at this data, it doesn't look as if the distribution of expenditures varies substantially by gender at all. In fact, they look almost identical. In nature, simply, it may be the case that women have a higher spike at 20,000 than men do, but on average, the distribution itself looks quite similar across the genders. If we were to go to the right, though, what I've got is again, all of this data broken down by people's favorite activity, their gender, age, etc. What we can do is we can break this down by that favorite activity. Okay? And if we look at the way people spend money based on their favorite activity, while there is some overlap in these distributions, it's not nearly as stark as it was in our male-female example. As a consequence, we're inclined to suggest that this may be one categorization of this data that helps explain a lot of the variation in our outcome of interest. Okay? That is, we think that people on average spend less if they spend their time going to clubs than if they spend their time traveling regularly. This is the basic idea behind Anova. It's also the idea behind our hypothesis test. Notice we could run a hypothesis test for the difference in average expenditures here for men and women, but we don't have a way of comparing more than two groups. Anova is such a way. Now, we're going to spend a lot more time on regression analysis later, which is going to generalize even Anova for us. So we're not going to spend a ton of time on it now, but I do want to introduce how to do this to all of you. So on the earnings Anova sheet that I've uploaded with these notes, there is a tab here that says Anova Practice 2, where what I've done is I've just taken all of the data from the previous tab and organized it by favorite activity. Now, when we're setting this up, we're going to want everything to be either in common columns with an identifier or rows, and so I've just set this up in columns. Notice we could run a hypothesis test here like we did in the last set of examples. I'll leave this to you to use the data analysis tool pack and run a hypothesis test assuming unequal variances and see if there's any difference really between male and female expenditures. Based on the visual evidence, it wouldn't suggest that there is, but you could look at this for further statistical evidence. What I'm going to do, though, is show you how to deal with Anova here. Again, it's in the Data Analysis Tool Pack, so what we're going to do is click on the Data tab, click on the Data Analysis option, and as we scroll up, what we'll see is Anova, single factor. This is the only example we're going to use in this class. A further research methods class in a marketing course may encourage you to spend more time with Anova. For our purposes, we're just going to think of single factor Anova. The assumptions of single factor ANOVA are basically, or for what we're going to need to do, we're going to need identical number of observations within each one of our, within our factor, okay, that is, we're going to categorize this by a single factor, which is somebody's favorite leisure activity, and within that there are separate groups, okay, people who spend their money on cars, on clubs, on outdoor activities, and on travel. So we're going to select ANOVA single factor, I'm going to hit OK, and it's just going to ask us where is all of our data. So the first thing we need to do is indicate whether or not it's in columns or whether it's in columns or rows. For us, our data are in columns, and the input range is here in cell A1 all the way through cell D201. So there should be 200 observations for each one of these. There are labels in the first row, and we need to indicate that. We can select alpha here to either be 0.05 or 0.01. I'm just going to leave it as 0.05 for the time being, and we're going to put this output here in cell K1. Once you've got these selected, you can hit OK. I put it on a news sheet by mistake, but that's all right. We can still take a look at it. Notice here that what we can do is look at the number of observations in each one of these categories. It's the 200 we observed on the previous slide. We can take a look at the average expenditure, and notice just looking at the averages, we do see the pattern that we observed on the histograms. The frequency distributions is that travel is by far the largest average spending category, clubs the lowest, and then cars and hiking somewhere in between. Now, ANOVA actually follows a different type of distribution than what we dealt with in our previous examples. We've only looked at standard normal distributions, or Z distributions, or T distributions. And in each one of those, we had to ask whether or not there was a one or a two-tailed test. In every application of ANOVA here, what we're going to do is we're going to evaluate this, and there's really no such thing here as a two-tailed ANOVA test. While we're testing for equality for all of these subpopulations, for all of these groups, we're saying we think, the null hypothesis is we think average expenditures here for cars are equal to average expenditures for clubs, are equal to average expenditures for hiking, are equal to average expenditures to travel. That is all part of the null hypothesis. The alternative hypothesis then is that one of those equalities, or at least one of those equalities, is broken. Okay, so if we see a substantial difference in expenditures by even one of these categories, it's enough for us to reject the null hypothesis. And we can evaluate this hypothesis by doing by two approaches. One, we can ask, is the F statistic, okay, the ANOVA here as a test, follows the F distribution. So just like before when we compared a T statistic to a T critical value, we're going to compare an F statistic to an F critical value, and we're simply going to ask, is my F statistic at least as big as my F critical value? If it is, we reject the null hypothesis. Similarly, we can compare our p-value to alpha. So I'm going to compare my p-value, I'm going to convert it to a percent, and I'm going to add a lot of decimals. And we're going to ask, is my p-value less than alpha? For us, we selected alpha to be 0.05, but we could have picked it to be 0.01 or 0.00001, and we can tell, given this p-value, that we would reject the null hypothesis. So looking at this table, it just gives us a way of verifying what we can observe looking at the data empirically and visually describing it, that the grouping, okay, the favorite activity, this single factor, as it were, and each of the groups within that factor do a good job of explaining the variation in average expenditures in this data. Again, we can see that by looking at either the p-value and asking whether that's less than alpha, or asking whether our F test statistic exceeds our F critical value. In either of those cases, we reject the null hypothesis that all of these groups have equal average expenditures.